Hello, dear students. Hi, all. Welcome to the class of numerical skill. Our topic for today is multiplication of matrix. Here it is a first form. It is multiplication by scalar. We already discussed this topic. So today we are going to discuss about multiplication of two matrices or multiplication matrix multiplication. So here it is first matrix and the second matrix, and here it is the product or multiplication of two matrices. Let us check how it is. So before going to multiplication, we should ensure that the columns in the first matrix and the rows of the second matrix must be equal. So columns in the first matrix, it is 3 here, and the rows in the second matrix. So both must be equal. So in this case, it is 3. The columns of the first matrix and the rows of the second matrix. Then only such matrices can only be multiplied. Then the result matrix, the product we are getting, the result matrix has the number of rows of the first and the number of columns of the second. Here it is the number of rows are 2, which is equal to the first matrix, number of rows of the first matrix. And the number of columns are here 2. It is equal to the number of columns of the second matrix. So, like these are the certain things we should remember while going to multiplication or matrix multiplication. So the first point it is, again I am telling, number of columns in the first matrix must be equal to the number of rows in the second matrix. All other matrices cannot be multiplied. If the matrices satisfies these conditions, it can be multiplied. Let us check. Can the two matrices can be or below be multiplied? So here it is, two matrices are given, matrix A and matrix B. Let us check the columns of the matrix A, it is 4. Okay. Then the number of rows in the matrix B or the second matrix, it is 4. So 4 columns and 4 rows. So both are equal. So we can say both matrix A and B can be multiplied. So let us take another one. Here it is two matrices. Here the number of columns of the first matrix, it is 2. And the number of columns of the second matrix, it is 3. Number of columns in the first matrix is 2, and the number of rows in the second matrix is 3. So 2, 3, which are not equal. So such matrices cannot be multiplied. Okay. So let us take one more question like that. Can the two matrices below be multiplied? So here it is two matrices, matrix A and matrix B. You want to say whether it is multiplicable or not. Here the number of columns in the first matrix, it is 1, 2, 3, 4 matrices are there. 4 columns are there. Then in case of matrix B, there is only 3 rows. So 4 columns and 3 rows. But are not equal. So such matrices cannot be multiplied. Since the number of columns in matrix A does not equal to the number of rows in matrix B, here we can say A into B is undefined or which cannot be multiplied. Okay. So let us check how to multiply matrices. Matrix multiplication. So we should check the first condition, number of columns of first matrix and the number of rows of the second matrix. Both are equal. That's the first condition. Then the second thing what we want to do it is multiply the elements of each row of the first matrix by the elements of each column of the second matrix. So it will be clear while doing the problem. Then number 3, take the sum of items and you can check it how the result matrix came. We already checked it. So it is the number of rows of first matrix and the number of columns of the second matrix. Okay, so let us take one problem. For example, here it is one matrix 1, 4, 6. Then into another matrix it is there 2, 3, 5, 8, 7, 9. So equal. First we need to check the first condition, it is satisfying or not. So the number of columns in first matrix, it is 3 here. Okay. Then the number of rows in second matrix is also 3. So we can say, oh, it is clear that both the matrices can be multiplied as the number of columns in the first matrix are equal to the number of rows in the second matrix. So Then we are going to the second stage. The second one, it is multiply the elements of each row of the first matrix by the elements of each column. So first elements of first row with first column. Row with the first column. So first row 1 into 2. So 1 into 2. Then 4 into 5. 4 into 5. Then 6 into 7. 6 into 7. So here the first row with the first column. Then again first row with the second column. This is the procedure. This is the way to multiply the matrices. So 1 into 3 plus then 4 into 8 plus then 6 into 9. Then take the sum. In case of first one, 1 into 2 plus 4 into 5 plus 6 into 7 will be 64. Then in the second case, 1 into 3 plus 4 into 8 plus 6 into 9 equal to 89. So this is the final answer. Then we need to check whether it is okay with the last condition. The result matrix has the number of rows of the first. The number of rows here it is 1. Check. And the number of rows of the first matrix it is 1. Then the number of columns of the second matrix. Number of columns here it is 2. Number of columns of the second matrix also 2. So we will get the result matrix only like that one. Should be equal to the number of rows of the first matrix and the number of columns of the second matrix. Okay, so this is what is the method of the way of multiplication. So let us take one more problem. Find the product of the matrices. Matrix A is equal to, here it is given, and matrix B it is this one. So first we need to check whether it is multiplicable or not. So here the number of columns of A, number of columns of A, 1, 2, 3, okay. Then number of rows of B, 1, 2, 3. So both are equal. So for first condition is over. Then we need to multiply the each row with every columns of the second matrix. So let us check. So first A into B is equal. So first row with the first column. This is the first row. First row with the first column. This is the first column of the second matrix. So here it is this one. 1 into 3. 1 into 3 plus 3 into 4. 3 into 4 plus 2 into 4. 2 into 4. Then first row with the second column. So first row. We are not changing the row. We are changing only the column of the second matrix. So 1 into 1 plus 3 into 2 plus 2 into minus 1. Then again the first row with the third column. So each row with every column. That is the condition. So 1 into 2 plus 3 into 3 plus 2 into 1. Then we are moving to the second row. So here we are going to the second row of the first matrix. Second row with the first column. The same procedure. 0 into 3 plus 2 into 4 plus 1 into 4. Then second row with the second column. It is 0 into 1 plus 2 into 2 plus 1 into minus 1. Then second row with the third column. 0 into 2 plus 2 into 3 plus 1 into 1. Then just like that, the third row with the first column, third row with the second column, then third row with the third column. So this is the way to the multiplication of matrices. So it will be, so you can calculate it. 1 into 3 is equal to 3. 3 into 4 equal to 12. 2 into 4 equal to 8. So 3 plus 12 plus 8. Just like that. 1 plus 6 plus minus 2. 2 plus 9 plus 2. Like that everyone. Then take the product. Take the sum of each element. It is 3 plus 12. 15 plus 8. 23. 1 plus 6 plus 6. 7 plus minus 2. 5. 2 plus 9. 11 plus 2. 13. So like other two. So this is the mode of multiplication of two matrices. I hope you are getting. So I given certain problems here for as an exercises. You want to do these problems in your notebook and submit in the classroom, Google Classroom. Okay. So there's question number one, matrix A and B. First we first you need to check whether it is multipliable or not. Then question number two, it is like this, matrix A and B, then matrix A and B. You want to find the same thing, the product of A and B. Three questions are here. Okay. Thank you. Thank you all.